Hello everybody, today I'm going to explain the solution to the second problem from the 2025 US Open Contest in the Silver Division, the problem compatible pairs. In this problem, we are given n unique ID numbers, and for each ID number we have n cows which share it. And these cows can only communicate in pairs, and basically the way they communicate is that the sum of the numbers in one pair must be equal to either A or B. And basically, in order to communicate, they can fulfill that condition. We want to have as many pairs as possible. So now the thing we want to determine is a way to obtain the maximum amount of disjoint communicating pairs, assuming the conditions from the problem are fulfilled. And we have here several examples in which we can see that we can pair, for example, in this case, the zeros and the fours, and then we can also pair ones and fours, and we can also pair we can also pair these two ones together, so the 2 plus 2. So in a way, the order in which these operations have been made gives a slight hint regarding the way you might want to approach the problem. And basically, as you see here, the last thing they did was to pair together the cows which make up, let's say, A over 2 or B over 2, because there can be some cows such that they can communicate together by let's say simply just placing with each other. But the main source of gain in terms of the number of these joint pairs will obviously be the pairs we can make with two different IDs, with two different numbers, and then have them communicate together. Now, this problem can give motivation to think at a lot of things. You can think greedily, you can think at even graph algorithms, like matching algorithms, but obviously we are in silver, and you can maybe have some brute force which passes some test cases, but maximum matching algorithms are way beyond the silver level, and probably they wouldn't even fit in time. So greedy is definitely the way to go. And now, when it comes to thinking greedy algorithms, you want to either start with smaller indices or start with larger indices. But now, if you want to start with the smaller indices, with the smallest indice, and try to match it with some larger numbers, you get into a dilemma in which you don't know exactly which number to match with, like whether you have to match it with uh, A minus that number or with B minus that number, but each of these choices has other implications depending on how the other numbers are placed in the array. So this is not exactly an optimal way. Now, if we go from the biggest numbers, again, the same question may arise, because if you want to match them from the biggest number, then you might have other implications later in the problem, which make things very difficult. But in a way, we will actually combine the two approaches. And what I ended up doing that worked was, when I iterated over the numbers, so I used the map data structure, I actually went over the numbers from the smallest to the largest. And every time I pass through a number, I only try to match it with numbers that are smaller than it, such that they add up to A or B. And the reason why I did this is because by the time my current number becomes bigger, the smaller numbers have no other choice. So you want to first match them with something that equals A, and then something that equals B. And then if none of these things happens anymore, then you match the cows with the same ID together. And I was a bit surprised when I saw that it worked at first, because I didn't expect such a simple algorithm to work. But after trying the other two approaches and also trying some other random stuff, I saw that it's better to just think in a simple manner, and it turned out to be the right move. So let me show you here. I kept a map where I kept for each number how many times it shows up. And then as I iterated in increasing order, I kept track of the complements. So A minus the first number and then B minus the first number. And here I prioritize the sum equals B, because if you have a 7 already and your two choices are 9 and 11, with a 4, you can actually have the bigger sum. You can have 7 plus 4, which is 11, but then you can't match 7 and 4 again. 4 might be, uh, and 4 it won't even be matched anymore with a bigger number, because the sums would become bigger and bigger. So I prioritized first matching according to the second sum rule. I did here the greedy to see a greedy choice to see how many pairs I can use. And then similarly, I did something like that for the first complement, because this first complement might get a chance later with the second sum, but the second complement will never get this chance again. And here I prioritize the cases when my current number is greater than either of the complements, and then I updated the map. And then at the end, I check the pairs such that they can be matched together. X times 2 equaling A or B. And one has to be very careful to avoid integer overflow, but again, the code is very simple, and you only have to be careful at ways to deal with this sort of restriction. So again, very important to pay attention to these details. And in order to recap, in order to solve this problem, you want to think greedily. You want to store the numbers or use the map data structure. And for a number, you want to match it with complements that are smaller than it, but also prioritize the second sum and then the first sum. Now, there might be other algorithms which work. There might be other greedy methods which also work. But again, this is the solution I used in the contest and the solution which I implemented relatively fast. If you enjoyed watching this video, please like it, subscribe to the channel and press the bell button in order to stay up to date with everything I do on the channel, especially as the season came to an end, the USACO season came to an end, and we are now going into the summer break, where as part of my plan to keep reaching out to the audience, I want to upload more USACO video solutions, more educational content, as well as maybe some other stuff such as code forces or other contests. Also, if you or someone else you know is interested in working more closely with me and joining my Elite USACO tutoring program, please check out the links in the description for ways to communicate more closely with me and for ways to become the next person who will achieve USACO success, just like 20 of my students have done this year with promoting to higher divisions. Until the next time, good luck with your summer practice, and I'll see you next time. Cheers!